We are going to start solving quadratic equations by factoring or using square roots. These two methods are limited and cannot solve all quadratics, but they are pretty easy for the quadratics that can be solved using these methods. Let's start solving by factoring. In order to solve by factoring, the equation must be equal to 0. Once it is, we factor. Question A has a GCF. And if two things are multiplied together and the result is 0, it means one or the other must be equal to 0. So one of these factors or both would be equal to 0. That's why we set each factor equal to 0 and then solve for the variable. You can leave your answer like this, or you can use set notation. When you're asked to find the zeros of a function, it just means to take that function and set it equal to 0. Let's factor. Once we have factored the quadratic, we set each factor equal to 0 and solve. First one, subtract 4, divide by 3. Second one, subtract 1. And again, if you want to write your answer in set notation, you may. It would look like this. Be careful here. In order to solve by factoring, the equation must be equal to 0 and only 0. That means we're going to have to multiply the binomials together using the distributive property so that we can incorporate the 48. And now we have a trinomial that can be factored. The factors are equal to 0. And we get two solutions. It's fine with me if you do that mental math where you set each factor equal to 0 mentally and solve. Here's set notation. Now let's look at this equation. This equation is unique. It can be solved using both methods. We've been factoring all along. In order to solve by factoring, we set the equation equal to 0. That means I'd have to subtract 9 from both sides. And then I could factor the difference of two squares, set each factor equal to 0, and we get two solutions. This equation could also be solved using square roots, and that's because there's no x term. When there's no x term, you can use square roots. In order to do that, you isolate the squared term. In this case, it's an x squared. I would start this equation by adding 7 to both sides. Now the x squared is isolated. I can take the square root of both sides to eliminate the exponent, and that would bring in a positive or negative. So we still have two solutions. Let's solve using square roots. We must isolate the r squared. So let's add 7 and divide by 4. Take the square root of both sides, we get two solutions. It's real easy to forget that plus or minus, so make sure you practice that. Find the zeros of the function just means we start off setting the function equal to 0. I'm going to subtract 5 and divide by 4. Take the square root of both sides. In the numerator, we have a negative. Square root of negative 5 will be I root 5, and in the denominator, we have a perfect square. So my solutions are positive or negative I root 5 over 2. Here, instead of a variable squared, we have a binomial squared. So we consider that the squared term. And in equation F, the squared term is already isolated. So we just start by taking the square root of both sides. That eliminates the exponent on the left and brings in a plus or minus on the right. Finally, to isolate x, we subtract 2 from both sides. That's it. That's our answer. You can leave it like that if you'd like, or you can use set notation. For the next one, set the function equal to 0. I'm going to subtract 18 and divide by 2. Take the square root of both sides. That eliminates the exponent on the left, brings in a plus or minus on the right, and the square root of negative 9 is 3i. So this method, you can see, allows us to find complex solutions, imaginary solutions. Finally, add 3 to both sides, and we have our two solutions.